Right now, a single server at a single IP address is answering secure requests for 1,000 completely different websites, each one showing its own correct certificate. That should be impossible. It isn't. For years, it actually was impossible. A certificate proves an identity, and the old rule was strict. One IP address could only ever present one certificate. That rule ran straight into a real shortage. Usable IP4 addresses are limited, and hosting companies needed to pack thousands of secure sites onto a small pool of them. The fix is called Server Name Indication, SNI, and its idea is almost embarrassingly simple. Have the browser just say which site it wants before the encryption even begins. That single spoken hostname arrives inside the very first message of the handshake, addressed to the one shared server that has to read it before any encryption keys exist yet. Armed with a name instead of a guess, the server turns to a shelf holding every certificate it's responsible for and pulls exactly the one that matches. Get that match right, and the encrypted padlock locks around the correct identity for the correct site every single time, no extra IP address required. One shared address, one whispered name, 1,000 certificates on standby. Let's follow one connection choosing its certificate in slow motion. Take one, picture the old world. A hosting company wants to run 1,000 small, secure websites. Under the original rule, that meant provisioning 1,000 separate IP addresses, one per certificate. That's expensive and, at internet scale, simply unsustainable. IP4 addresses are a genuinely finite resource, and burning one per small website was never going to work forever. SNI changes the starting assumption entirely. Instead of the IP address identifying the site, the browser tells the server directly in the opening handshake message which hostname it means to reach. The very first TLS message, the client hello, includes an extension field carrying one plain text hostname, b.example.com in this case. So the connection begins ordinarily too. Your browser opens a TCP connection to the server's one shared IP address, the same address every other hosted site on that machine also shares. That hostname has to travel unencrypted, and there's a good reason why. The server needs to read it before it can even choose which certificate to use to start encrypting anything at all. The server receives that name and turns to its certificate shelf, a lookup table mapping every hostname it hosts to its own dedicated certificate and private key. It searches for an exact match. Does any certificate on this shelf cover the name b.example.com? Out of 1,000 candidates, precisely one qualifies. If a browser connects without offering any hostname at all, some older clients still do, the server has no way to choose and quietly falls back to a single default certificate instead. But for the overwhelming majority of modern traffic, the match succeeds instantly. The server now knows exactly which private key and certificate to present for the rest of this handshake. With the right certificate selected, the rest of the TLS handshake proceeds completely normally. Keys are exchanged, both sides confirm each other, and an encrypted session is established. From your browser's point of view, nothing about this felt unusual, a normal padlock, a normal page load. Behind the scenes, one server just answered correctly out of 1,000 possible identities. Multiply this single exchange by every visitor to every one of those 1,000 sites, all day, all sharing the exact same IP address, and the scale of what SNI quietly enables becomes obvious. The honest trade-off, that opening hostname really does travel unencrypted, in plain sight, on the network, which means anyone watching the traffic can see which site you're about to visit. That visibility bothered privacy-focused engineers enough that a newer extension exists, Encrypted Client Hello, which wraps even that early hostname inside its own layer of encryption. Encrypted Client Hello needs its own bit of setup first. The browser has to already know a public key for the server before it can hide the hostname, which is why adoption is rolling out gradually rather than everywhere at once. SNI also explains a familiar browser warning. Connect to the wrong hostname on a shared server, and you often see a certificate mismatch error. Proof: the shelf lookup found no match for the name you actually typed. One shared IP address, one plainly spoken host name, one certificate pulled from a shelf of 1,000. That's how a single server answers correctly for every secure site it hosts, every single time. That's how it runs. Next time a padlock appears instantly on a small shared hosting website, you'll know a quiet whispered host name made that exact certificate possible. Check out our other videos and follow how it all runs for more. See you in the next one.